Solve each equation by completing the square. So what we're going to do here is a technique to turn this type of problem into the type of problem you just worked, one that you can solve by taking a square root. So as always, let's just start by writing down the problem as is. And now what we want to do when we're completing the square, we want to take the number that's by itself and we're going to move it to the opposite side of where all the variables are. So here I've got the negative 70 on the same side as the variables. I'm going to move it to the other side, so that means adding 70. And so that gets me n squared plus 2n, and now I'm going to leave some space here, equals 70. And I've just left that space there because we're going to add something to that in just a moment. Alright, so now what I'm going to do is I'm going to turn this statement over here into a perfect square, something that I can write as some quantity squared. And the way I'm going to do that is I'm going to look at b, the coefficient of the linear term. So the variable that doesn't have an exponent, look at its coefficient. So I'm going to say b equals 2 over here to the side. So now what I want to do is I want to find what happens if I divide b by 2 and then square it. So in this case, b is 2, so if I do 2 divided by 2, that's 1. 1 squared is 1. And that's the number that I'm going to put in here. I'm going to add 1 to it. So again, where that came from is I took this number, I took half of it, half of 2 is 1, and then I squared that. 1 squared is 1. So I'm just going to add 1 right there. But if I add 1 to one side of the equation, I have to add 1 to the other side. So now this gives me n squared plus 2n plus 1 equals 71. And the cool thing about this is now that I've done this, I can rewrite this as some quantity squared. And that something is this. I take the square root of the first term, so the square root of n squared is just n, and then I take half of b. So half of b would be positive 1, and so this thing right here is equal to n plus 1 squared. Now once I'm here, I learned just a few minutes ago that if I have something squared and I take the square root of it, it gets rid of the squared term. So let's take the square root of both sides. So if I take the square root of this, I get n plus 1 equals the square root of 71, which let me grab a calculator. And I find that the square root of 71 is going to be 8.43, roughly, but it's going to be plus or minus 8.43. So now what I need to do is set up two problems from this. I can say, in one case, because there are two possibilities here, n plus 1 could equal positive 8.43. It's also possible that n plus 1 equals negative 8.43. And so I've set up two problems that are going to have each one its own solution. Let's do this one first. I want to find what n is. So I subtract 1 from both sides, and n would be 7.43, just like that. So there's one of my solutions. And now to find the other one, I work over here. I'm going to subtract 1 from each side, and here n would be 9.43. And those are my two solutions. N can either be 7.43 or negative 9.43. Alright, let's do the same thing over here for number 5, just to get more practice. I'm going to scoot us over this way so as to get a little more paper. Problem number 5, we know that b squared minus 4b minus 89 equals 7. And we need to get all the numbers on one side, all the variables on the other, so we're going to add 89 to both sides. That gives me b squared minus 4b. I'm going to leave some space to add something in there. 7 plus 89 would be 96. So now I'm going to add something in here to make this a perfect square, and that something is going to be half of b squared. Now b, remember, referring to the coefficient of the linear term. So I'm going to take half of negative 4, that's negative 2, and then square that. Negative 2 squared is positive 4. So I'm going to add 4 right there, but if I add 4 to one side, I have to add 4 to the other. So this gives me b squared minus 4b plus 4 equals 100. Now I'm going to rewrite this as a perfect square, and remember that's going to be the square root of the first term, which is b, and then half of this coefficient, so half of negative 4 is negative 2. So this is b minus 2 squared equals 100. Now, to get rid of this squared term, I'm going to take the square root of both sides, and I find that b minus 2 is going to equal the square root of 100, which is plus or minus 10. Now this means I have two options. One option is that b minus 2 equals positive 10. The other option is that b minus 2 equals negative 10. And now I can solve both of those equations. It's easy enough. All I have to do is add 2 to both sides, and I find that b could be 12, or b could be negative 8. And those are my two solutions.